We will discuss about the Kuralon fibers versus PVA fibers. Further in detail, we are discussing origin of these fibers, chemical composition, chemical nature, physical properties, chemical properties, tensile strength or tensile properties, and use applications of these fibers. When we discuss about the composition, Coralone fibers, it is a polyacrylonitrile based synthetic fiber. On the other hand, PVA is polyvinyl alcohol based synthetic fibers. These are synthetic fibers, but the composition difference is Coralon polyacrylonitrile and PVA is P for poly, V for vinyl, A for alcohol based synthetic fiber. Further, we are discussing about the properties. Coralon is known for its high strength and resistance to chemical and abrasion, while PVA exhibits good water solubility, making it suitable for certain applications like water films. Chemical nature of these fibers is Coralone polymerized from acrylonitrile monomers, while PVA is derived from polymerization of vinyl acetate, which is then hydrolyzed to form polyvinyl alcohol. As we have also discussed in initial slide, it is polyacrylonitrile based and PVA is polyvinyl alcohol based fiber. When we discuss about the applications of these fiber, Coralon used in various applications including ropes, nets, and textile where strength and durabilities are essential or critical. On the other hand, in case of PVA, it is used in water soluble applications such as laundry, bags, embroidery, stabilizers, and certain medical applications. So they have different end uses. PVA is preferably used in water soluble applications. Acid resistance of these fibers. Coralon moderate acid resistance and can degrade in highly acidic environment, especially at lower pH level, even at below 4. The degradation of depends on the duration of exposure and specific acid concentration. So the variables are regarding resistance or regarding stability are one is concentration of acid and further is the time of exposure. In case of PVA, generic PVA fibers are also have limited acid resistance. They tend to hydrolyzed or weaken in acidic environments, making them less effective in application where they are exposed to strong acids for a prolonged periods. While we comparing above the alkali resistance, Kuralon known for excellent alkaline resistance which makes it highly suitable for use in concrete reinforcement. Kuralon can withstand its physical property even in a highly alkaline environment such as the concentration is above 12. In case of PVA, in the journal PVA fibers also exhibits good alkaline resistance. Even the level of resistance can vary based on the manufacturing process and specific formulation. Higher grade PVA fibers are designed to withstand alkaline environment like a concrete. When we compare about microscopic behavior or microscopically these fibers, Corallon fibers appears uniform, smooth and have good consistent diameter across their length. They usually have dense and solid eternals. In the case of PVA, PVA fibers are also smooth, but variations in manufacturing can lead to slight irregularities in their diameter. Under high magnification, some PVA fibers may appear more porous than branded Coralon. So we can say Coralon is more smooth with a consistent diameter across the length as compared to PVA fiber. The physical properties of these fibers, Coralon density is 1.29 to 1.3 gram per centimeter cubic, while in case of other it is around 1.3, similar to the Coralon, as 1.3 is average density of Coralon and same is near about the density of PVA fiber. Water absorption absorbs moisture easily due to hydrophilic nature of PVA. Water absorption, while in the case of PVA, generic PVA fibers are also hydrophilic, but variation in polymer structure can affect their water absorption capacity slightly. Third property is shrinkage. Kuralon exhibits very low shrinkage when exposed to high temperatures, while on the other hand, PVA standard PVA fibers may exhibit slightly higher shrinkage than Kuralon in heat environment. Microscopic we have already discussed in previous slides. Tensile properties of these fibers. Typically, Kuralon fiber range 1.2 to 1.8 GPa depending on the grade or classification of Kuralon fiber. While for the case of PVA, it has strength about 1.0 to 1.5 GPa. Elongation is for the case of Kuralon is 7 to 12%. While for PVA it is 6 to 10%. Young modulus is typically around 30 to 40 GPA for the Kuralon, and in case of PVA it is less as compared to Kuralon, it is around 25 to 35. So the tensile properties of Kuralon fibers are better as compared to PVA fiber. Performance, when we are discussing about the performance properties of these fibers, concrete reinforcement. For the case of Kuralon fiber, it has excellent for reinforcing concrete due to its alkaline resistance, high tensile strength, and bonding with cementation material. It improves the crack resistance and ductility of concrete. In case of PVA, also effective in concrete reinforcement, but performance may not be as high as Kuralon in extreme conditions due to possible variations in manufacturing. So we can say the performance properties of Kuralon fibers are better as compared to PVA. Durability, high durability in long-term applications, particularly in civil engineering and constructions. For the case of when we discuss about PVA good durability but subjected to degradation if exposed to certain harsh environment like extreme acids. Next is fiber matrix interaction. Strong bond with cement matrix resulting in enhanced mechanical properties in composites. On the other hand, in case of PVA, similar to Kuralon, PVA fibers bond very well with the cement matrix but may vary in performance depending upon fiber type and manufacturing. So, performance properties of Kuralon fibers are better as compared to PVA fiber. In the end, we can conclude that Kuralon offers superior tensile strength, modulus, and performance in extreme condition, especially alkaline environment, as compared to generic PVA. While PVA offers comparable properties in many areas, but may vary more based on their specific formulation. They are generally used in applications where less strength performance is required or cost of is a significant factor of the production. So this was the overview of Coralon fibers and PVA fibers. Hope we will see you in next lecture with another important topic, important fibers. Thank you, Allah Hafiz.